All right, well, I think I've pushed all the right buttons. We will all see how it goes. So today we're going to be talking about sort of the next step in the process of making memories. And specifically, we're going to be talking about how information gets transferred over from our short-term memory, even if it's something that's a little bit more manipulated in our working memory, how that gets transferred over to our what we call our long-term memory. So it's been proposed that the main processes involved in making a memory are threefold. So we have encoding, storage, and retrieval. And so this idea of retrieval, it refers to the transformation of sensory information, so the information that we're getting from our surroundings and taking in, the transformation of that information into a representation of a kind that then can be stored in our memory. And so storage then is how we retain the information that we've recoded. So how do we hold on to these representations that we have made about our experiences? And then retrieval then has to do with how we pull out, how we get access to the information that we have stored in our memory. And however, it's important to note that these aren't thought of in like this nice, neat, linear, step-by-step sort of function, but rather that they are interacting and are interdependent on one another. And so this means that if you have a hard time encoding something, then it's going to be really hard to store it well, which then also has implications for retrieval, because it's going to be really difficult to try to find as well. You can think of it as like a filing cabinet. If you don't have your different, let's say that you have things filed by a person's last name, right? Maybe you are a therapist and you have case files, and your case files are organized A to Z, patient last name. If you are aware of that information, right, you have a way of transferring, okay, this file goes here because this person's last name is Brown, so I'm putting it in the B's. Then you can go back and retrieve it because you know exactly where it is. But if you don't have that kind of system set up, if you're just taking patient files and just throwing them into the filing cabinet, just one after the other, it's going to be a lot more difficult to retrieve because you didn't do a very good job of organizing it in the first place. So to kind of demonstrate this interdependence that exists between encoding and storage and retrieval, I'm going to have us do a little activity. So if you can, grab a piece of paper and a pen and pencil. If you prefer to type on your computer, that's fine. You can open up a Pages or a Word doc. So I'll give you a couple of moments to just get something that you can write with, whether that's physically or digitally. Okay, so what we're going to do is I'm going to read off a passage. I want you to listen carefully to it and then try to remember as much as you can. Once I'm done reading the passage, write down everything you can remember. So here is the passage. The procedure is actually quite simple. First, you arrange items into different groups. Of course, one pile may be sufficient depending on how much there is to do. If you have to go somewhere else due to lack of facilities, that is the next step. Otherwise, you are pretty well set. It is important not to overdo things. That is, it is better to do too few things at once than too many. In the short run, this may not seem important, but complications can easily arise. A mistake can be expensive, as well. At first, the whole procedure will seem complicated. Soon, however, it will become just another facet of life. It is difficult to foresee any end to the necessity for this task in the immediate future, but then again, one can never tell. After the procedure is completed, one arranges the materials into different groups again. Then they can be put into their appropriate places. Eventually, they will be used once more, and the whole cycle will then have to be repeated. However, that is part of life. So that's the end of the passage. Go ahead and write down as much as you can remember of what I just read to you. If you're still writing, that's fine, keep going. But for those of you who have written down as much as you can remember, I'm curious, what did you think of this task?
All I can remember is the beginning, like 2 or 3 instructions, and then how you ended it. Like the middle is just gone.
All right, so we have a prime live example of the primacy and the recency effect, right? You remembered information from the beginning and the end, but everything in the middle just kind of gone. Okay, what were some other people's takes on this task?
I kind of have the same thing where I remember the first sentence and the last sentence, and then I just have random words in the middle.
Okay. Did it seem like a difficult task to people?
I think for me it was easy to like still kind of remember like the middle chunk, but I have no idea exactly what the task is. It was just so like obscured in like all the other words that you were saying.
Absolutely. Yeah, that's exactly the point. This is a difficult task because you're trying to make sense of all of this information and remember it and then retrieve it, right? And so, like you just pointed out, if you don't have a good understanding of what's going on, aka if you don't have a good strategy for getting information in there in the first place, it's going to be a lot harder to retrieve that information. So let's try this task again. So this time, I want you to keep in mind that the passage is describing the process of washing clothes. So this passage is all about doing laundry. All right, and we'll see how much better you do this time around and what you remember. So here's the passage again. The procedure is actually quite simple. First, you arrange items into different groups. Of course, one pile may be sufficient depending on how much there is to do. If you have to go somewhere else due to a lack of facilities, that is the next step. Otherwise, you are pretty well set. It is important not to overdo things. That is, it is better to do too few things at once than too many. In the short run, this may not seem important, but complications can easily arise. A mistake can be expensive as well. At first, the whole procedure will seem complicated. Soon, however, it will become just another facet of life. It is difficult to foresee any end to the necessity for this task in the immediate future, but then one can never tell. After the procedure is completed, one arranges the materials into different groups again. Then they can be put into their appropriate places. Eventually, they will be used once more, and the whole cycle will then have to be repeated. However, that is part of life. So take another stab at how much you can remember and see if there's a difference between the second time around and the first. I'll give everyone one more minute just to see if there's anything else that comes up in your mind.
I still don't know what the procedure is, but I feel like the second time around I got a better holistic grasp of it. The first time around I wrote down bullet points of beginning, middle, end, but I didn't get a clear, concise view of the first and the last. I think I was scattered kind of throughout. So
yeah, that's great. And you know what, that speaks exactly to this idea of the different ways in which we encode information then has implications for how we store it and how we retrieve it, you know. And by even having that cue of, oh, this is about laundry, okay, that helps you then to better organize that information. And like you said, Julia, have this more sort of like linear, continuous idea of what's going on, rather than maybe getting the bits and pieces, you know, having some bullet points here and there. Great. All right, well, thanks for participating in that. I saw some of your faces as I was reading the passage at first, so I could tell it was hard. Thanks for hanging in there. And all right, so let's go ahead and talk about some of the factors that influence our ability to encode memory. So one such factor that impacts our encoding is the process of rehearsal, obviously. And so this, you know, we can think about going back to like the phonological loop concept. You know, it's this idea that there's this internal verbal repetition that we have. And there are actually two different kinds of rehearsal that have been proposed. So one is just a more simple form of rehearsal, and it's called maintenance rehearsal. And like its name sounds like, you're just trying to hang on to those pieces of information. So it's a much more low level sort of basic function where you're just repeating items over and over, either saying it in your head or, you know, if you were shown a picture, right, trying to think about, okay, what were all the things that I saw? And so this kind of rehearsal, this maintenance rehearsal, means then this information is only available to us as long as we can hang on to it in our working memories. So if it leaves our working memory, that's it, it's gone. So in comparison, there's something called elaborative rehearsal. And this is, in comparison to maintenance rehearsal, more complex. And it involves this process of constructing and integrating information in ways that allow for these interconnections in our long-term memory. So essentially these links in our long-term memory. And so we know from a variety of studies, we'll talk about some of them, that information that is elaborated upon is more efficiently stored in long-term memory. So the more links that you can make between that information and in your long-term memory, the better you are going to be able to recall it versus just repeating it to yourself over and over, just simple rehearsal. So one such study that really supported this idea came from researchers by the name of Craik and Watkins. And so in this study, they had participants listen to word lists, and these word lists had words that had different lengths to them. So they weren't really controlling for like the length of the word. And then at the end of each list, the participants were asked to state the last word that was on the list that started with a G. And so participants were then throughout the study given 27 different lists total. I hope they got some sort of decent compensation because that's a lot of list learning to do. And so eventually participants developed the strategy of just listening for G words and then holding on to the most recent one that they heard. That way they could report the right word when the list ended, when each of the lists ended. So for example, if they heard garage, they'd hang on to that until they heard another G word like giraffe. And then if another G word came up like giant, they'd drop giraffe and hang on to giant. But if giraffe was the last one that they heard, they were like, great, I've held on to that, and that was the last G word on the list. So participants hung in there with all of this, and then the researchers switched up the rules. At the end of all 27 of the word lists, once they got through all of them, they were like, okay, now what we'd like you to do is we would like you to recall all of the G words from the list. And so if the process of just rehearsing a word is what helped it move into long-term memory, then the G words that were rehearsed over and over again should have been held onto for a longer period of time. But the participants, they only recalled 25% of the G words, and that was regardless of how much time they had to rehearse them. So whether a G word was the first word on the list and they were just rehearsing that over and over, or if it was the G word was really close to the end of the list, didn't matter. They still could only remember about 25% of the G words that they heard. And so all to say, this study then suggests that, again, we need more than just maintenance. We need more than just rehearsal to transfer information to our long-term memory. And so another important factor is how deeply we are processing information as well as we are in this encoding process. And so there are these depth process models. They're also called levels of processing. And they focus on the interaction and integration of existing memory, our encoding, and our retrieval methods that are critical to being able to use long-term memory in a functional way. And so here with a levels of processing model, the idea is that how deeply an item is processed is related to how likely someone will successfully encode that information. So essentially, an increase in depth at the processing stage will lead to an increased number and kinds of associations between whatever objects, items, events, ideas that you are trying to remember. And this will then lead to a longer, what they call a memory trace, essentially a more long-lasting memory in long-term memory that then can be accessed. So it's deeper, there are more associations, it's richer, and therefore you're going to be able to recall it better. And so the idea here is that the deep, meaningful kinds of information that is processed leads to more permanent retention, better remembering, versus more shallow sort of sensory level processing that takes place. And so this deep processing, like I said, it involves the meaning of the information. So for example, when you consider a word's meaning, like whether it would fit accurately in a sentence, you know, if it would fill in that blank that was in the sentence on the test appropriately or whatever, or if you think about other associations or past experiences you might have had with that word, what it brings to mind, that is deep processing. Versus a more shallow processing, it involves paying attention to more of the physical aspects of a stimulus. So whether a word is presented in capital letters or not, for example. It can also, shallow processing also can pertain to sound information. So whether it rhymes with another word, for example. And also another factor that plays a role in this levels of processing idea is what kind of task are you also involved in? What are the demands of the task on you? For example, do you know that you'll have to recall that information later or not? There are some memory tests that are used in cognitive assessments. Some of them, you have the person practice the information and you tell them, okay, now remember that because later I'm going to ask you to repeat those words again. And other tests, you just have them repeat the words over and over and you say, okay, great. You move on. And then you have to come back and be like, remember when I told you that story? I want you to tell it to me again. So obviously that's going to have an impact on your encoding, whether you know what the rest of the task looks like or not. Also, depending on how difficult the task is, are you having to multitask? Are you having to push a bunch of buttons and answer a lot of questions? Or is it a simpler task where it's not taking as much of your attention? And then also things like time constraints on a task as well. So, do you have all the time in the world to encode information and make a response, or are you under some sort of time constraint? And so we're going to explore some of the evidence for this idea of levels of processing. And so this comes from a study by Craik and Lockhart. And this study then helped them to eventually propose this levels of processing model. And so in this study that they carried out, participants were asked to complete either an easy task that involved deep processing of information or a more challenging task that had more shallow processing involved. So the easy task that had deeper processing was a sentence completion task. So they had to respond yes or no about whether a word properly completed a sentence or not. So it was easy in that all you had to do was say yes or no, but it was deep processing in that you had to think about the meaning of the word. And then the more challenging task that had shallow processing involved in it was this sort of letter pattern task. So with this one, participants, they had to determine if each word had a certain pattern of consonants and vowels to it. So again, they have this pattern that they're supposed to be looking for, and then they're answering whether or not that pattern appears. And so the outcome of this study was that participants had better recall on the sentence completion task. So they were better able to remember the words that they were asked to evaluate in their goodness of fit for a sentence in comparison to what they had seen with the letter pattern task. And so this supports the idea that our memory is a function of like continuous operations versus like just step by step. And also that deeper processing helps us to have a better memory trace. So that is a more long-lasting memory, essentially. They say like memory trace, but it's a memory, right? This representation of something that you have experienced before. And so there's also been some support for this idea of deep processing facilitating better recall through some neuroimaging studies as well. And so this evidence has revealed that there is more involvement, that is more brain activity during tasks that involve deeper processing. And there's a specific fMRI study by Wagner and colleagues from the late 90s. And in this, they found that deep processing, that is processing the meaning of stimuli, led to an 85% accurate recall rate versus just 47% for information that had been more shallowly encoded. And they also found that there's this specific pattern for deeper processing as well. So there's this certain pattern of activity that arose for deeper processing. And so we will move on to the criticism of this, like so many things that we'll talk about in cognitive psychology. we'll talk about the theory, and then we'll talk about what people have said is wrong with it. So in this case, what people have said is wrong with this levels of processing idea is essentially that, well, in order for this to make sense, the nature of the encoding task, that is the way that the person is learning the information, it has to be really similar, if not the exact same, as the nature of the retrieval task. So there's a study by Morris, Branford, and Frank that supported this idea. This will actually be the basis of one of the labs that you'll be doing later on in the semester. And so in this study, what they did was they varied the aspects of acquisition, that is learning, the learning aspect of memory, and they also varied retrieval methods that participants were to use. So for learning the words, participants either learned words based on their meaning, so based on semantics, and that's deeper processing, or they had to learn words by rhyme. So this is a phonemic, based on the sound of the word, and this is shallower processing. And then so we have an acquisition period that's either deep or shallow processing, and then we have a retrieval period that's also based on cues that are going to elicit deep or shallow processing. And so what they found was that there's this match, there's this congruence, this similarity between the encoding task and the retrieval task. And that is what allowed for better recall. So as an example, the conditions in which participants were deeply processing and deeply recalling, or doing more shallow learning based, more shallow processing based learning, that's a long string of words, and then having to recall them in a more shallow way, did better than those who had this mismatch between the conditions of the acquisition and the retrieval. And so another question has also been raised about a little bit more sort of an existential question, but well, how do we even know what is deep processing versus shallow? You know, what are the distinctions between those? How do we know what that is? And this criticism was put forth by a famous cognitive psychologist, Elizabeth Loftus. We will talk about her more when we talk about like memory distortion and like eyewitness testimony. But essentially she was wondering, well, what's deep, what's shallow, who defines that, how do we know that? And so those were some of the criticisms that came after the development of the levels of processing model. So now we're just going to continue talking about some of the other specific factors that play a part in our elaborative rehearsal, that is our more complex rehearsal, as well as the retrieval of this more complex rehearsal. And so one factor to consider when we're thinking about encoding is this idea of encoding, the encoding specificity principle. And so this essentially is arguing that a person's ability to retrieve information is fully dependent on the relationship that exists between the kind of processing that they did during the encoding, and also the aspects, the context of the retrieval itself. And so a study by Tolving in 1983 demonstrated this, that there are two things that actually affect long-term memory retrieval. So how information is initially encoded, and then the way in which it is retrieved, so the context of retrieval. And in another study, Tolving carried out a study with another researcher named Thompson, and they found that items aren't just encoded in our memory, just in isolation, devoid of anything else, but our really rich memory representations include the context of the item's encoding. So how we encountered the item, where, when, the kind of associations that we maybe made in the moment when we encountered it, like, was it hot or cold? What season was it? How were we feeling? Was somebody just like really pissed off and in a bad mood when they remembered that? Were they happy and they just got an A on paper and they felt really good and then this happened? And so if we go back to our computer metaphor and the idea that, well, computers are a helpful metaphor for the human mind, but it's not this exact representation. We're not exactly like computers. Going back to that idea, the transference of information from short-term memory to long-term memory, it isn't like a process of just copy and pasting or just stamping something down and having just this exact pure representation of that event or object exactly as it appeared, devoid of anything else that happened. But rather, what we remember is highly contextualized. And so now we're going to talk about some of the aspects of context that then impact our encoding. And so one of these factors is called state-dependent learning. And state-dependent learning, it emphasizes the importance of a match between our internal cues, our own experiences, with then the recall cues that we use to try to remember those experiences. And so our emotional state is one such state that influences our learning. And so in a study, participants were asked to remember a time in which they felt like really happy or really sad. And then they learned lists while they were reportedly sort of in this mood state. So the researchers were like, think about that, kind of really transport yourself back to that feeling, see if you can kind of hang on to how you were feeling as you're doing this task of learning words. And then they were asked to recall the words on the list in either a congruent, so a matching mood state, or an incongruent mood state. And so similar results were found by some other studies as well, supporting this idea of our congruent or a matching states of mood between when we learned something and when we recalled it actually bolsters our memory for that. And then another state in which our learning is dependent is our physical state and our surroundings. So there's this really cool, I was like, when I read this study, I was like, honestly, this sounds like one of the cooler studies to both like conduct and also like be a part of. Because Godden and Badley of Badley and Hitch, see, I told you he was going to come up. Godden and Badley, they conducted a list learning task in which participants were learning lists and retrieving lists in one of two conditions. So they were either learning while they were underwater or on land, and then they were recalling while either underwater or on land. So some combination of those. And again, these recall conditions, the recall conditions that match with the encoding conditions, that is, if you were underwater when you learned the information and underwater when you recalled it, was better than when there was a mismatch. If you were underwater when you learned and then on land when you tried to remember it. And another factor is the use of imagery in our encoding process. And so imagery can help bolster our associations between material in our memory and helps us to recognize information and recall information. And an example of this is something called the method of loci, or the mind palace. If you've ever watched the BBC show Sherlock, or if you've ever read the books, this is a memory technique actually that Sherlock uses. That is one of the ways in which he's able to make sense of all of these different clues and solve crimes. I actually have a short clip that I'll show you of this, because I think his companion, Dr. Watson, does a great job of sort of explaining this idea. If it will come up on the PowerPoint. All right, well, hold please, just give me one moment. Oh, good, it's no longer stored on the slide, okay. All right, well, that's okay. Let's just, okay. I told you to pause. I don't want to listen to this ad. Okay, sorry about that. Thanks for hanging with me during these technical difficulties. I'm skipping this ad on YouTube. Oh, there's quite a lag between the things that are happening on screen and then what I'm clicking on. So, okay, so thanks for hanging with me. We're going to try this again. So I apologize about the quality of this clip in terms of the resolution. It's not great. And if anybody is not able to hear the sound, please let me know and I'll troubleshoot that. But anyway, this is just a scene from the show Sherlock, and he's in the midst of trying to put all these different clues together using his mind palace.
Drug. How did it get into our systems? How? There must be something buried deep. Get out.
What?
Get out. I need to go to my mind palace.
The what?
He's not going to be doing much talking for a while. We may as well go.
His what?
Oh, his mind palace. It's a memory technique, a sort of mental map. You plot a map with a location. It doesn't have to be a real place, and then you deposit memories there. Theoretically, you can never forget anything. All you have to do is find your way back to it.
So this imaginary location could be anything, a house or a street?
Yeah.
It's a palace. He said it was a palace.
Yeah, well, it would, wouldn't it?
You are not the... Count.
You're muted.
Your mic is...
Okay, so an example of how you can use mental imagery and pair it with concepts, and then go back to that imagery to help you remember those concepts. Okay, let me go back to sharing my PowerPoint. Thank you all for bearing with me. All right. Okay, so a final factor that we're going to talk about that has to do with encoding is how related the information is to us personally. And so this is something that's called the self-reference effect. Humans are just innately egocentric. That means we're focused on ourselves, not necessarily in a selfish way. But when things or events are related to us, we're actually better able to remember them. So this idea of when we're involved in the main character of our story, right, we're better able to have these really rich, well-remembered connections between things. Again, let's talk about some empirical evidence for this. So Rogers, Kuiper, it's always a time, and Kirker, what they did was they gave participants different instructions of how to process words. So they were asked to process words based on their appearance, based on how they sounded, based on their meaning, or based on how they like personally applied to somebody, like having to think of an example in which, you know, maybe they encountered that object or something like that. And there was some levels of processing that was involved in this, right? The more shallow processing, that is the sound and appearance-based processing, didn't result in really good recall. The deeper processing, that is processing the words based on meaning, did better, but ultimately the best processing happened when participants were asked to think about that word in relation to themselves. And so one possibility of why this happens is that, well, we just richly produce a set of cues based on ourselves because we know ourselves well, right? We're experts in ourselves. And then you can then easily link that information to the new information that you're trying to learn. And then another possibility is just that, well, you might rehearse material more frequently if it's related to you, right? So again, just sort of this idea of, well, we are egocentric. We do find meaning and relevance in things more when they have to do with us. And a great example of this self-reference effect are something called flashbulb memories. And so Brown and Kulik, who've done some foundational research in flashbulb memories, they describe these as just these really vivid, highly detailed memories that endure for quite some time. And these are memories that have a lot of personal significance, and they have a lot of emotion that are tied to them as well. And for me, one of my flashbulb memories is 9/11, which might be dating myself, so you can figure out how old I am. But I was in the 4th grade. I was in Mrs. McKim's class. I remember exactly where my desk was in the classroom as we just sat in silence and were just stunned watching the footage on TV. The video clips of people who were jumping out of the tower windows because they knew they couldn't get out fast enough, that I, as a 4th grader, like that just has stuck with me forever. You know, right now I'm going back in time and I'm playing that footage that I saw of people running away from the towers covered in debris, people jumping out of windows. And so it's really stayed with me. And so this flashbulb memory of 9/11, it's not simply a narrative of on the morning of September 11, 2001, you know, planes were flown into the Twin Towers and also the Pentagon and, you know, things like that. It's not this narrative factual presentation of what happened. It was what happened from my viewpoint and the personal information that was involved. And so another way of thinking about these flashbulb memories is that they are events that are sort of burned into our long-term memory. The flashbulb idea is based on old cameras that you would have like one charge, and that would be you would fire that would be the lighting for the picture, and then that would be it. You wouldn't have that charge anymore. That bulb would be burned out. And so there's this idea theoretically that they're burned into our minds, but we've actually seen some evidence that, well, these flashbulb memories they actually, like all of our other memories, they're actually like reconstructed. We reassemble them every time we think about them, rather than just rehearsing them verbatim, pulling them out exactly as they were. And we do see this a lot with people's memories, even for flashbulb memories that are still, they're really vivid, they're really emotionally charged. Is that oftentimes the more people tell the story of that memory, the more that there are embellishments, there are details that are added, maybe details that are left out. And this is often unconsciously, people aren't usually like spinning these stories, consciously trying to be like, oh my gosh, and then this happened, and then, and then I fought a bear, and then I won, but slowly these things creep in over time, the more that they recall that information. And so now we're going to talk about some of the ways in which we've learned or gotten evidence for this idea of storage and retrieval. And so cases where there's brain damage, neurosurgery, and also people who have undergone electroconvulsive therapy, ECT, to treat depression have shown us the importance of the hippocampus in our storage and retrieval processes. And so various cases have shown us that when the left temporal lobe is surgically removed, verbal memory gets knocked out. When the right temporal lobe is removed, visual memory gets knocked out. When people have undergone ECT for depression, this is usually when people have had what's called medication-resistant depression. So they've tried all sorts of antidepressants and other medications for depression, and their depression hasn't gotten better because of it. And so in these cases, we've seen that if somebody receives ECT to both sides of the brain, it impacts both verbal and visual memory. And similarly to the surgical removal of the temporal lobe, getting ECT on the left side of the brain, it hurts your verbal memory. Getting it on the right side hurts your visual spatial memory. And the thing with ECT is that it does sort of have this dose dependence, which means that the more that you have it, the more that you undergo ECT, the worse that your memory tends to get. So it's not necessarily the case that, if somebody has ECT once, that suddenly, oh no, like they can't remember anything. It does take quite a bit of time. It is cumulative. And then just some words associated with these memory impairments that we've seen and studied from these brain damage and neurosurgery and ECT cases are retrograde amnesia and then anterograde amnesia. And so retrograde amnesia is the loss of someone's memory before they got injured or were in an accident or their brain got damaged or whatever it is. Whereas anterograde amnesia means that they're not able to form any new memories after the point of injury or accident or whatever. And so again, those retrograde, you've totally forgotten your past, but you can remember your present. With anterograde, you can remember your past, but you can't remember your present. And so in the last portion of this lecture, we're going to talk about, well, how do these memories stick? What is sort of happening at the neural level that is causing this information to get stored? What is putting these files into the filing cabinet? And so a neuroscientist, Donald Hebb, he wrote that he believed that learning is accomplished by assemblies of neurons, and that they have the ability to become more efficient in their connections with one another. And a really popular saying that's kind of associated with Hebb's idea about learning and memory is the neurons that wire together fire together. Actually, I think I have that backwards. I do have that backwards. It's the neurons that fire together wire together. And so essentially, the more that certain neural pathways are activated, the more often that they're used, the stronger they are and the more efficient they are. So they're getting better over time with how they're able to transmit that information. And so this is, we can think about this as being somewhat related to the idea of like, well, practice makes perfect, right? The more practice that you have with that, the better you are at it. And so this strengthening of the synapses that happens at a electrochemical level, it's called long-term potentiation. I'm not going to go into all the details of it, but this long-term potentiation is the process that is helping to strengthen these synapses and to help us have stronger memories and build stronger connections between ideas and events. And so a final memory process that we're going to talk about real quick is called consolidation. And so consolidation is this process of stabilizing a memory after time, after it's first acquired. So essentially this process of storing the memory. So getting the information all squared away. Again, if we go back to our filing cabinet example, consolidation is, you know, when you're ready to put that file back, you're looking through, you're making sure that everything's, you know, organized. Maybe the papers are supposed to go in a certain order and you're making sure, okay, everything's there. Okay, now let's go ahead and put it in its final place in the filing cabinet. And there's this idea that there's actually this, there are two stages or two phases of consolidation that happen. And so the first stage, this happens minutes to hours after we've learned something. So there's this sort of initial consolidation process, this initial gathering up of materials and putting them into the file folders to then be transferred into the filing cabinet. And so this is thought to be the result of changes at the level of the neurons. And then the second stage happens days and even up to years afterward. And so this is thought to be the result of long-term memory changes. And so maybe the way that things are stored changes, or maybe you're able to integrate the information that you first consolidated, maybe with future information that you've gained. And so that is essentially the sort of, you know, highlights of how we make memories. We're going to talk about long-term memory in further detail next week, but that is where we will end lecture today. Does anybody have any questions